Okay, so in lesson 1 we learned how to factor and reduce simplifying rational expressions. In this one we're going to start doing some operations. So multiplying and dividing rational expressions. The same rules that apply to multiplying and dividing fractions with integers is the same as multiplying and dividing rational expressions. But you have to remember just to state all the non-permissible values as you go along. So we're going to simplify each expression, and notice that there's a multiplication sign between the two of them. So I think first off what we want to do is we want to express our non-permissible values. So only one is here, so A cannot equal 0. And we're going to take a look at where can we reduce, what are reducible in the numerator and the denominator. So the 9 and the 3 work okay. And I'm just going to replace that with a 3. The 2 and the 5 don't work, but the 8 can be reduced, right? So this 8 can be taken out here, and this will just be a to the first. So after we finish, that's all we can do. We're just going to multiply across. 2 times b squared gives us 2b squared. In the denominator, 3 times 5 is 15 with a. And you're done, because you can't reduce any more than that. You can also reduce binomials where you can. So first thing we want to do here is express our non-permissible values. X cannot equal negative 2 or 0. And then we want to do our reductions. So we take a look at the binomials that can be reduced. So x plus 2's can go. Here this 2 and this 4 can be reduced. Here this x and this x squared can be reduced. And that looks like it. Oh no, this x and this x can go. So in the numerator we end up with 5 times x plus 4 minus 4. And in the denominator we end up with 12. And I just double check, there's nothing here that can be reduced, so that's how I know that we're all good there. You know what, you guys, I want to change this up so it'll work out a little better for you. Let's do this instead. 10 squared, c squared over 10 is going to be equal to 5d over 2c. Here's the answer. It's going to be cd over 4c cannot equal 0. The answer. Okay, so in the next one, now we're going to divide. Okay, and we've divided. See, it's the same as when you're working with rational numbers. We're just going to flip the second fraction and multiply. So in this part of it, we'll just write in 7n cubed over 4 times negative 12. Now we've got to square everything inside the bracket, so this will be 49n squared. Where can we reduce? Okay, well the 12 and the 4 will work with each other, so that ends up being negative 3. The 7 and the 49 will reduce, so that'll end up being 7. And this n will just end up being n. So here we'll go 3 times n is 3n, and in the bottom we have 7. Non-permissible value here, n cannot equal 0. Same thing with the second one. We can also times x minus 3. For this one now, non-permissible value here, x cannot equal 0 or 3. Where can we cancel? Well, let's get out the red pen. There and there. Here the x's can go. And here the 5 and the 2 can go. And I think that's it. So we'll switch back. What's left in the numerator is going to be 3 times x plus 5. What's left in the denominator? 2 times 2 is 4. I'm just going to do a double check here. Is there anything that's reducible? No. So I'm done. Okay, try the check on page 222. for the check on 222, if you have this, sometimes the software duplicates and I don't know about it. We're going to do this as our B. Okay? And I'll give you the answers for both. Maybe do this in a different color. Okay. Lastly, we're going to be factoring and simplifying. So this part's pretty simple too. So if you remember your factoring from IAPC in grade 10, that means that this will be a piece of cake for you. In this first one, I think we're going to make this a lot easier. We're going to change this to a multiplication sign here. So let's multiply here. So we think of here. What are the factors of 20 that could give you 9? And then in the denominator, we're going to multiply 2x times x, and the factors of 8 that, when we multiply it with the 2, could give you 6 in the middle, so 4 and 2 would work okay there. That'll be a minus and a plus. Note, over here, you got to do greatest common factor. Right? So this is a difference of squares. Greatest common factor in the denominator. Let's do non-permissible values here, but actually I'm going to do this, take this a further step. There should be 2 times x minus 1. Once we do the greatest common factor out of there, so it means that x cannot equal 1, negative 4, negative 5. Get out the red pen, start canceling where you can. These x plus 5s can go. These x minus 1s can go. This x plus 4 can go. And I think that's it. So in the end, we just multiply across. The only thing that's left on top is going to be equal to x plus 1. And the only thing that's left in the bottom is going to be 6. There you go. For B, greatest common factor out of here. Now here's the hint. You know that when we flip this and multiply it, something in the numerator is going to have x minus 7. Otherwise, we pretty much wouldn't ask this kind of a question. This is looking a lot like x minus 7 there. So 3x squared minus 12, greatest common factor of 3. So that'll be 3 times x squared minus 4, which is the difference of squares, x plus 2, x minus 2. Okay, let's get together with this one. Let's take a guess here. Let's say that this is minus 7. Well, you have to multiply that to get you to 63. That, of course, is going to be a 9. And in order for this to be a minus 12 and a minus 63, that has to be a plus. Here's another greatest common factor here. Let's put it into red. So it's 3 times x plus 3. Okay. And let's start our cancellations. Where can we cancel? X minus 2's can go. X minus 7's can go. This 3 here can go. So we end up with, in the numerator, we end up with an x plus 3. And in the denominator, we end up with 3 times x plus 2. Did I do my non-permissible values? No. That's why you want to do them right off the start, because you can forget them pretty easily. Okay, try the check on 224, and you are done. I'd be happy to answer any questions you might have in class tomorrow.